Welcome to EDU World Space.
All right, quite a few parts to this question here. We have two crates, one with a mass of 4 kilograms and one with a mass of 6. They're sitting on a frictionless frozen pond. We have a woman wearing golf shoes, basically saying she's stationary. She pulls on the 6 kilogram crate with a force that gives the crate an acceleration of 2.5 meters per second squared. What is the acceleration of the 4 kilogram crate? A free body diagram of the 4 kilogram crate, also a free body diagram of the 6 kilogram crate. And then we want to know what direction the net force is on the 6 kilogram crate and which one has a larger magnitude, as well as what that actual force is. So all these kind of lead into each other. So starting off with the first question they're asking, what is the acceleration on the 2.5? So we know we'll call this the crate 1 and crate 2. All right, acceleration on 1 is going to be 2.5 meters per second squared. And we'll go ahead and we'll put C2 a little farther down so I don't get too ahead of myself here. And what is it going to be for C2? If this is your, we'll call this the 6 kilogram one because that's the one that's originally getting acted on, and this is the 4 kilogram one. Well, it's going to be the same. It's 2.5 meters per second squared. And that's because they have to move in unison on a frictionless surface. A great way to kind of visualize this is if you have two things tied together and you're rolling them on a table, one doesn't become faster than the other one, catch up and hit it, unless you stop it. So they're going to be the exact same. And then the second thing it wants is free body diagrams of both of these. This will help you visualize the problem. So we have the two squares here. We'll call this the 4 kilogram one, this the 6. Here we have the force the lady is pulling. We're also going to have a weight pushing down, as well as a normal force keeping it from falling. And then we're going to have tension in the rope. That tension is what's carrying us over here entirely. Then we're also going to have a weight value bringing it down and a normal force keeping it from falling. So those are your two free body diagrams. And the question is, so we're down here to C, what is the net force on the 6 kilogram crate? So just from seeing this here, the value we're going to use here, we've noticed we have accelerations and masses. We're looking for force, F equals ma. So intuitively, the tension force here caused by this guy back here is going to be force times mass times acceleration. They share an acceleration. So mass is the deciding factor. Mass is less here, and mass is going to be more here. So the net force will be forward. That tension value will be less because the block behind it weighs less, and they share an acceleration. So let's put some math to that and figure out what these forces look like. So F equals ma. So for here, we would know mass times acceleration. So we'd have 6 times 2.5. All right, and that's going to give us 15 newtons. And over here, it would simply be 4 kilograms times 2.5 meters per second squared. And that's going to give you 10 newtons. So that being the split, the net force is going to be 5 newtons that way with the 6 kilogram one. Now, what is the total force to pull both of these? Well, to do that, you're going to need to overcome the tension and have the force of the front one. So for the force total, which is the final question they're asking, that's going to be 25 newtons. It's not the same as the net on this one body. It's the total of the entire equation. So we have 24. The net here, you're going to find that you have 15 minus 5. You're going to have 5 newtons net coming this way. That's the force of the lady pulling, or the force on this object, but it's going to be 25 newtons total. Accelerations are going to be exactly the same, and that pretty much covers it.